that when I have square root of AB, it is actually square root of A times square root of B. Okay? Then the next one, when I have A over B power n, what does this expand to give me? A n over B power n, or we can write A n times B power negative n. They are the same thing. So again, I'm going to introduce the square root symbol. A over B power half must therefore be A power half over B power half, which means that square root A over B is square root A over square root B. Okay? Laws of indices, nothing new, just a recap. Okay, next one. What does square root A times square root A give us? This gives us A. What about cube root of A to the power of 3? Still A. Quite common sense, right? Then if I rewrite it as fractions, A power half times A power half, what does this give me? Still A, because they are equivalent. I'm rewriting the square root as power half. So here, you can do the equivalent also. Next thing, I want you to tell me whether square root of A plus B equals to square root of A plus square root of B. Okay, this is the question. Are they the same? If you say no, 4 plus 9 equals to square root 13. Is this a surd? This is a surd. This is a surd. Okay, right hand side, I have square root of 4 plus square root of 9, which is 2 plus 3, which is 5, not equal to left hand side. So this is not equal. So it is easy to prove that something is wrong. Okay? So obviously, we know that A minus B is also not going to be equal to square root A minus square root B. Can? Okay, next thing is on simplifying of surds. So let's take a look at work example number 4. This part will just take a short time only because it's quite easy. Okay, simplifying, what does that mean? We have part A, root 2 times root 8. I want to be able to combine them into a single surd if possible. I want to be able to square root wherever possible. Can I square root 2? Can I square root 8? Can I square root 8? Cannot. But can I combine these two? It gives me square root of 16, which is 4. Is there a plus minus? Is there a plus minus? Who is not sure whether got plus minus and wants me to teach? Okay. Look carefully at the question. Is this a positive number or a negative number? Or maybe both? Okay. Let's compare. What does this mean to you? This equals to positive or negative, right? So what do you say about this again? What do we call this? We call it positive, so this means positive. What is this? Negative. Okay. Now, what about this? Equals to? Negative 2. Positive or negative? It's simply negative, right? What about this? What is this going to be? Simply 2. Is there possibility of negative in the last example? No, it is a positive number. Okay, there isn't a plus minus, so don't introduce it yourself. These are positive numbers. So this is going to be positive also. When is it that there will be a plus minus? When you get questions such as this. Okay, x squared equals to 9. When you are asked to solve for x, what do? X equals to plus minus square root 9. Why is it that I put plus minus over here? Okay, x is the unknown. We see that when I have positive 3 or negative 3, when I substitute them back into my x squared, I still get positive 9. So this is what I always tell myself, and I tell my students, of course, that when you are the one, this is the question here, when you are the one introducing the square root symbol, I say square root, I didn't say cube root. When you are introducing the square root symbol over here, you put in the plus minus. Okay? When the square root symbol is already given to you, for example, in work example 4, part A, it is already given to you. You follow the sign given. It is just positive, you use just positive. If they say it is negative, then it will be negative. No need to guess. Okay? So this is my approach. So square root 16, we get the answer as 4. So you see, I have a surd over here. Then square root 8 is actually a surd also. If you key in square root 8 in your calculator, you see a whole string of numbers without any repetition. So surd times surd can give us a rational number. Okay? This is one way we can do this question. Another way, I show you an alternative. Square root 2 times square root 8. Okay, square root 8 can be separated into two factors. What are they? What are the two factors? 2 times 4, okay. 2 times 4. Then this gives me square root 2 times square root 2 times square root 4. Right? This part is equivalent to this part. Right? Okay, next. Here's the magic. Square root 2 times square root 2, what do I get? These two multiplied together gives you 2. Okay, 2. Square root 4 is 2. Then you get 4 also. Same. Two different approaches. Can? Okay, next one, part B. Square root of 18. Okay, now I want to separate it out. Because square root 18 can be simplified further. What is a good option to factorize it into? 2 times 9. Or we can also do 3 times 6, right? Possible also, isn't it? Okay, if I do 2 times 9, what do we get over here? Square root 9, right? So this is 3 square root 2. Okay, this is my first option. If I go with this, what can I do? Can I separate? Square root 3 times square root 6. Does that get me anywhere? Yes, how? Okay, so this is square root 3 times square root 2 times 3. Okay, then square root 3 times square root 2 times square root 3 equals to 3 square root 2. Same. But which do you prefer? First one, because we try to separate it out into factors that are perfect square. Save us some trouble. Otherwise, when you are here, right, you may get stuck. You don't know what to do already. Okay? Your turn to try. Practice now 4. How do you get 3? This one? Okay. From this step, this is square root 3 times square root 3 times square root 2. Okay? So your turn to try. Practice now 4A to D. So we are supposed to simplify square root D, square root of 80 times square root of 12 divided by square root 16 ni squared. Okay, I saw that you have different approaches. I saw that some people take 80 times 12, but that's not a good idea. Then after that, you still need to square root that big number. How are you going to square root it? Without a calculator. So we want to break it down into factors. 80 can be broken down into factors. 1 times 80, 2 times 40, so on and so forth. We try to find factors that are perfect squares. Are there any perfect squares as factors? What are they? 5 times 16. Why did I choose 5 times 16 instead of 4 times 20? Why did I choose 5 times 16 instead of 4 times 20? Because I want to be able to square root as large a number as I can. And I know that if I choose 4 and 20, it is going to come out to become 4 times 4 times 5. So this is another perfect square, which is 16 times 5. So I might as well go straight to 16 times 5. Okay? So this is 16 times 5 times square root 4 times 3. And in the denominator, I know very clearly it's 16. Square root 16 times 5. So 4 square root 5 times 2 square root 3 divided by 16. We can do some cancellation. 1 and 4. 1 and 2. So I'm left with square root 15 over 2. Is that the correct answer? Okay. If you don't have the textbook to check the answers, then what should you do during the exams? Use your calculator, press this. Use your calculator, press this, see whether it's the same. If they are the same, then you know that your answer is correct. Then you look at my working. Is it very clear that I did not use a calculator? Yeah, because every step is quite doable with mental sums. But if your working causes me to doubt whether you use a calculator or not, then you may be penalized. Okay? Yes? Change everything in the same way. Okay. Sounds alright also. Okay, I just want to show you a few more examples. Yes, yes, yes. Huh? 16 over 4. 60 over 4. So your answer is square root 60 divided by 4 like this. Square root 60 is not, okay, it is a surd, but I can simplify. Square root 60 can simplify into square root of, now I want two numbers, when multiplied together, gives you, one of it is a perfect square. I think one of it will be 4 4 and, what is it? 15. Okay, so this will be 4 times 15 over 4. So square root 4 times square root 15 over 4, which is? Okay, 2 times root 15 over 4, which is root 15 over 2 . So this is the most simplified one. This is not simplified yet. Okay, so this one will not give you the final answer mark. Okay, next one. I want you to take a look at practice now 6, part A. 7 plus 2 square root 3 multiplied by 5 minus square root 3. I want to expand this out, simplify and expand and simplify. Okay, how do you do this? Rainbow, yeah, rainbow. It works the same way. 7 and 5 to get 35. 7 and negative root 3 plus, it's a negative now. So minus 7 square root 3. You can just copy this down into your textbook right now. 2 and 5 plus 10 root 3. And lastly, this is the part where you may face some problems. 2 root 3 times negative root 3. What do we get? 2 root 3 negative root 3. Okay, what's this? So this will be negative 2 times 3, negative 6. Okay, minus 6. Then we can simplify. 35 minus 6 is 29 plus 3 root 3. Simple algebra? Yes? Now Now we shall try part B. 4 minus 3 root 2 square. At this point, I want to know, have you memorized this? A minus B power 2. Who has memorized and is using this? Raise your hand. Raise your hand, raise your hand, I want to see. Okay, put our hands. How many of you are using this? A minus B, they have A square minus AB minus AB plus B square, A square minus 2AB plus B square. How many are using this method? The slowly expand out one. They are equivalent lah, but it's just extra step only. Okay? Both of these methods can be used over here. Can you try it out now? In part A and B, when I take surd, these are surds. Surd and surd. Surd times surd give me surd. Okay, next one. Here I have surd times surd again, give me surd. So surd times surd give me surd. Let's try part C now. Let's try part C. We have 3 plus 2 root 5. 3 minus 2 root 5. Okay, what does this give you? Expand it out. Try expand. So 3 and 3, I get 9. Minus 6 root 5 plus 6 root 5 minus 4 times 5. So 9 minus 20, negative 11. Okay? Why did I highlight these two? The green and the blue one. What did happen to them? Yeah. So surd times surd give me rational number. Okay? So it's not always that surd times surd give you surd. Sometimes it give rational numbers also. Okay, and these two obviously they cancel each other out lah. So what's so special about this question that causes this to happen? What's so special about this? These two surds, do they remind you of something? What does it remind you of? A plus B, A minus B. Right? Where in this case, A is going to be equal to 3 and B equals to 2 root 5. Okay, we know that A plus B, A minus B gives us something. What does it give us? A square minus B square. Yes. The reason is because when I expand everything out, I get A square plus, minus AB plus AB minus B square. Right, then these two cancel out. Just like what is happening over here. That is why my final answer is going to be equal to A square minus B square straight away. And this process, these two, they are known as a pair of conjugate surds. They are like partners. They come in a pair. It so happens that it is like in the form of A plus B, A minus B, such that when there are surds, you multiply, you get a rational number. Okay? So let's see whether you are able to identify and write down immediately what conjugate surds are. So for example, if I have a surd that looks like this, 1 plus root 2. Can you tell me what is the conjugate surd? And 1 minus root 2. Okay. So these two, they come in a pair. If I multiply them together, I will get, okay, so surd, conjugate, then product. Mentally, can you tell me what's the answer? 1 minus 2 equals to negative 1. Okay? Next, let's try 3 minus root 5. What is the conjugate surd? 3 plus root 5. Okay, what is the product? What's the product? A square minus B square, come on quickly. 3 square minus 5, which is 4. Alright, let's try a few more examples. Let's have root 7 minus 5. And what is the conjugate? What is its partner? What is the partner? Square root 7 plus 5. Okay, and what is the answer for the product? 7 minus 25. Okay, so negative 18. Okay? More examples. Let's try 2 plus 3 root 7. Okay. What about the other one? 2 plus 3 root 7, the other will be 3 root 7. Okay, good. So the product will be 4 minus 9 times 7. So 4 minus 63, negative 59. Okay? Are you able to tell conjugate surds just by looking already? Okay, why is this important? Because we come to the next part, which is called rationalizing the denominator. Okay, rationalizing the denominator. Let's take a look at work example number 7. 6 over root 2. This over here is a number. If you key in a calculator, you get a certain number, 6 divided by root 2. This is a fraction. Where is the surd? The surd is in the denominator, right? Is the numerator rational? Look at the numerator. Is it rational? Yes. What about the denominator? Is it rational? No, it is not rational. So then the question says, look, read the question. Rationalize the denominator. They want you to rationalize the denominator. Change from irrational to rational. So I don't want the root 2 in the denominator anymore. I want a rational number. So what do you think I can do to both numerator and denominator to get rid of the surd? What? Square root 36? What do you mean? This is equal to square root 36. Okay, how does that help me? Then it becomes square root 18, is it? That's not what I'm looking for, but good try. I want to get rid of the root 2 in the denominator. Times what? Square root 2 where? Times square root 2 where? Both sides, both numerator and denominator. I can do that, right? Square root 2 times square root 2. Okay, what happens if I do this? What happens to my denominator? 2. Is it rational now? Yes, this is called rationalizing the denominator. So what happens to my numerator? 6 root 2. Can simplify? 3 root 2. Yeah. This is called rationalizing the denominator. I don't want a surd in the denominator. Okay? And you must know how to choose what to multiply. In this case, multiply by root 2. Okay? Next one. Part B. 7 over 2 plus root 3. Is the denominator rational? Is it rational? No, it is not. I want to rationalize it. What do you think I should multiply with for both numerator and denominator? What should I multiply by? How about 2 plus square root 3? 2 plus square root 3 will not give you a rational number. But when we try multiplying by 2 minus square root 3, and 2 minus square root 3, then I know that the denominator is going to end up with, we did a lot of practice, right? Okay, we did a lot of practice over here. What is the denominator? 4 minus 3 or 9? 3. Okay, numerator. Numerator? 14 minus 7 root 3. Okay, that's the answer. 14 minus 7 root 3. Rationalizing the denominator. So, in work example 7, I gave you 2 examples. The first one was simple. I just multiply by square root 2. The next one, I have to multiply by a, what is this called again? Conjugate. Surd. So you do the same for the numerator in order for them to be the same. Today's homework, Practice now 7. Question 1, 2, 3. Go ahead and practice.